How safe is X-ray inspection of food? X-ray inspection of food is reliable and 100% safe. X-ray inspection is widely used by food manufacturers worldwide who strive to protect consumers' welfare, safeguard their brand reputations, and comply with national and international regulations and legislation, as well as standards set by retailers. However, some manufacturers still have reservations about adopting X-ray inspection as a method of product inspection. They're concerned their staff will object to bringing X-rays into the workplace, and that consumers could switch to a brand that has not been subjected to X-ray inspection. Whichever way you look at it, food that has passed through an X-ray inspection system is as good and tasty to eat as it was before it was scanned. For over 20 years, food manufacturers have been using X-ray inspection technology to ensure product safety and quality. X-ray inspection gives food manufacturers exceptional levels of metal detection for ferrous metal, non-ferrous metal, and stainless steel. The technology is also extremely good at detecting other physical contaminants, such as glass, mineral stone, calcified bone, high-density plastics, and rubber compounds. In addition, X-ray systems can simultaneously perform a wide range of inline quality checks, such as measuring mass, counting components, identifying missing or broken products, monitoring fill levels, measuring head space, product in-seal inspection, and checking for damaged products and packaging. Food manufacturers are under significant pressure to ensure their products are safe. Manufacturers are not legally obliged to use X-ray inspection as part of their safety procedures, but they are subject to many international regulations and retailers' standards. These regulations and standards oblige manufacturers to undertake thorough product inspection programs, with X-ray inspection proving to be an invaluable element within product inspection systems as a whole. And since production line speeds have been increasing steadily over the years, manufacturers have had to find reliable inspection methodologies that can work effectively in fast-moving and complex manufacturing environments. Food that is passed through an X-ray inspection system is as good and tasty to eat as it was before it was scanned. Reassuringly, it is a fact that X-ray inspection is safe and it doesn't harm food. That's because X-ray radiation levels used are so low that they have no negative effects on food safety, flavors, texture, or nutritional value. What's more, X-rayed food does not harm consumers, nor do X-rays harm people who work with X-ray inspection because, again, levels of radiation used are low. The use of X-rays is very strictly monitored to ensure that no one is at risk of excessive exposure. Radiation is all around us, but what is it? Energy from a given source is generally referred to as radiation, and different forms of radiation have been harnessed by science for use in many different types of equipment that we often take for granted in everyday life. There is a great deal of radiation in the world, much of which does no harm to human beings, does not affect food, and neither does it damage our environment. Radiation, both man-made and natural, is known collectively as background radiation. It is all around us, and over 80% of it is from natural sources. Examples of natural radiation can include natural heat and light from the sun, radiation from the ground, and gamma rays from radioactive elements. Examples of man-made radiation include microwaves from an oven and X-rays from an X-ray tube. The main sources of radiation that we human beings are exposed to are radon gas, cosmic radiation, gamma rays, medical, and internal radiation. The accrued radiation dose is the most important measure. To control and monitor radiation levels, radiation is measured in what are known as sieverts, a measurement named after Professor Sievert, who studied the effects of radiation in depth. Where radiation is present in medical or industrial environments, human beings are usually only allowed to be exposed to very low levels of radiation. So to measure these, the sievert unit is often divided up into small units, such as millisieverts, which are 1,000th of a sievert, and microsieverts, which are 1,000,000th of a sievert. Each person on Earth is exposed in a typical year to around 2,400 microsieverts of naturally occurring ionizing radiation. That's 2,400 millionths of a sievert per annum. This figure of 2,400 microsieverts is much higher than the radiation levels absorbed by previous generations, and that's because radiation used in medical science has caused an increase of around 18% in radiation levels. Nevertheless, levels of radiation to which humans are exposed are still extremely low. Natural exposure. Radiation is part of everyday life. To give you an idea of how you absorb radiation naturally in the course of everyday life, if you were to eat one banana a day for a year, you'd absorb around 36 microsieverts of ionizing radiation from the organic materials present in those bananas. And if you were a frequent flyer, your high-altitude location would mean that you absorb around 8% more radiation a year than non-flyers, around 200 microsieverts a year. By comparison, air cabin crew and pilots absorb about 10 times as much per year, around 2,000 microsieverts. Occupational exposure. Human and food radiation absorption levels well within safety tolerances. The typical absorption level of 2,400 microsieverts, to which humans are exposed, by far exceeds the amount of radiation exposure received from a properly installed X-ray inspection system. In fact, the typical maximum dose rate close to an X-ray inspection system is less than 1 microsievert an hour. In addition, there is no scientific evidence of any health risk to humans at doses below 20,000 microsieverts per year, which is the adult limit for occupational radiation exposure when working with radioactive material. What is the difference between X-ray inspection and food irradiation? Food processors use X-rays in two separate ways: to inspect for contaminants or product defects, and to destroy bacteria. The process to destroy bacteria is known as food irradiation, and involves radiation doses up to 10 million times bigger than those used in X-ray inspection to inspect for contaminants and product defects. X-ray inspection of food doesn't cause it to become radioactive, just as a person doesn't become radioactive after having a chest X-ray. There is scientific evidence to show that X-rays don't harm food. A 1997 study by the World Health Organization, WHO, confirmed that food radiation levels up to 10,000 sieverts don't affect food safety or nutritional value. Food that passes through an X-ray inspection system spends about 250 milliseconds in the X-ray beam. Like all other X-ray machines, those used to inspect food are built to the highest levels of safety so that they can do the jobs for which they were designed, protecting factory operatives and protecting the food they're inspecting. A typical X-ray inspection system comprises three elements: an X-ray generator, a detector, and a computer to analyze the X-ray image. Passing out of the generator through a small window, the X-ray beam goes straight through a collimator, which changes the shape of the beam into a fan shape. These fan-shaped beams then pass through food being inspected and are picked up by the detector. The whole system sits within a stainless steel cabinet, and a lamp stack on top indicates the system's operating status. X-ray inspection systems design and manufacture must adhere to comprehensive and strictly enforceable legal regulations. These laws stipulate that units should be absolutely safe to work with, even if an operator has to stand next to it for every single hour of their working day. In practice, though, operators spend very little time next to X-ray inspection units, especially when so many production lines are highly automated. Once installed, the unit must subject to a final detailed X-ray survey. If the unit passes, it receives a certificate issued by the manufacturer or an independent inspector. In addition, operatives are given detailed and exhaustive training in how to operate the X-ray inspection unit, with particular emphasis on maintaining high levels of safety at all times. Find out more about X-ray machine safety. So as you can see, X-ray inspection of food ensures product safety and quality at all times. The fact is that food that has been X-ray inspected is as safe to eat as it was before inspection. And please remember, X-ray inspection is not food irradiation, whose purpose is to eliminate bacteria. Furthermore, X-rays are electrically generated and man-made, so they can be turned on and off. You can always be reassured that staff who work with food inspection X-ray systems are protected both by legislation and by machinery design. To find out more, visit www.mt.com/X-ray-safety.